Today we will be discussing analysis of variance or ANOVA. ANOVA is a statistical analysis to determine if there is a difference in the mean or average of three groups or more. In student t-test, we are just comparing two groups. In ANOVA, we will be comparing more than two groups. Remember, if you are comparing average, it means that your variable is a continuous variable. And then the statistical tool that you need to use will be student t-test if there is just two groups, and ANOVA if it is more than two groups. Just like the t-test, we have assumptions that we need to follow or fulfill. But for the purpose of this video, we will not indulge in checking these assumptions. The assumption of ANOVA is, first, the observations are drawn from normally distributed population. Second, observations represent random samples from the population. That means that the sample we will analyze later would fit the histogram of the population. Then, the variance of the groups are equal. That means that the dispersion of the data from one group should be the same as the other groups that you are comparing. If all these assumptions are not fulfilled, then you need to use the Kruskal-Wallis H-test. However, for this video, we will disregard these assumptions for the sake of giving examples. When we are performing the analysis of variance, we can have two hypotheses, null and alternative. The null hypothesis is stated as there is no significant difference in the mean or average value among the groups. We have here our symbol for the null hypothesis. Then here we have the X bar, which means that is the average value of the group that you are comparing. We have here a subscript 1, 2, 3 until k. This is the average value of the first group. This one is the average of the second group. This one is the average of the third group, until you max the number of groups you want to compare. It could be groups or dependent on strata. For the alternative hypothesis, we can state it as there is a significant difference in the mean or average value among the groups. At least one group has an average different from the other groups. This is the symbol of our alternative hypothesis. One group designated as I is not equal to other groups designated as group J. X bar sub I is not equal to X bar sub J for some I of J. Remember, the groups you are comparing should be 3 or more for the analysis of variance. For example, we are comparing blood sugar level. This variable is a continuous variable, and we are trying to compare it across several BMI groups. Our null hypothesis can be stated as there is no significant difference in the mean blood sugar level among the underweight, normal weight, overweight, and obese patients. You have 4 groups. In using mathematical notation, we can state the null hypothesis as X bar, the average blood sugar of underweight, equals average blood sugar of normal weights, equals average blood sugar of overweight, equals average blood sugar level of obese. It should be equal across the groups when the analysis of variance is done. The alternative hypothesis is quite complicated. We can state it as there is a significant difference in the mean blood sugar level among the underweight, normal weight, overweight, and obese patients. At least one group has an average that is different from other groups. This is the simplest mathematical notation of the alternative hypothesis. However, depending on what you want to know in your research, for example, you want overweight group to be focused on in determining the blood sugar level, you can expound this mathematical notation. When you expound it, it is possible for you to have 3 alternative hypotheses. For example, in H sub 1, do the underweight groups have a significant difference in their average blood sugar level in comparison with the other 3 groups? As you can see, the groups obese, overweight, and normal weight are all equal, then all of them is not equal to the underweight group. For the second alternative hypothesis, the underweight and normal weight are equal. The overweight and obese groups are equal. but when you compare them as pairs, they are not equal. The third alternative hypothesis, the underweight, normal weight, and overweight groups have equal average blood sugar level, but the collective 3 groups is not equal to the obese group. It is complicated when you have many alternative hypotheses. What we are doing with analysis of variance is that we are just disproving the null hypothesis of the groups having equal average value. We will just go back to our Orange 3 from the previous session. By the way, the Orange 3 software that is installed in my laptop is version 3.31. If ever you will be seeing this video in the future and the process I discuss here did not give the same outcome, then maybe you should upgrade to the latest version. Remember, in the analysis of variance, it should have 3 or more groups. Let us now go to our box plot. Let us check our continuous variable, this one. Then we will look for 3 or more groups. By the way, here in the variable aspirin, if you're going to think about it, were they given the aspirin? However, in our dataset, there are missing values. If we are going to check the feature statistics, the initial aspirin status will only use the student t-test because there is only 2 groups. 0 label means they are the group that did not have the aspirin, while 1 had the aspirin. At 6 months, there is already 3 groups. It was interpreted by our software as real 3 separate groups and performed the analysis of variance. Looking at the feature statistics, the aspirin status at 6 months has 2% missing values. Same with the aspirin status at 12 months. It has missing data points. What Orange 3 has done is that it has separated them to 3 different groups. But in reality, it should not have happened. It should have been student t-test because there really is just 2 groups. You just have to discard a group with the label missing. To make it easier for us, I just did not include aspirin in our statistical analysis. Let us look for other variables with more than 2 groups. Here in the educational level, it has 5 groups. Another variable is the income, which has 5 groups or levels. We only have 2 analyses of variance, education level and income. Is there a pertinent relationship between HbA1c level and education level? You can see here, let us just enlarge this. This is the gray line. That is the average for each group. Group 4 average is 10.330. Group 2 is 10.578. Group 1 is 10.66 and so on. Here we have the result. The p-value is 0.678, which is bigger than our alpha of 0.05. This is not statistically significant. Is there a difference in the initial HbA1c level among the groups without formal education, with elementary education, with high school education, with bachelor's degree, with master or PhD? This is our scientific inquiry. Our null hypothesis will be there is no significant difference in the mean initial HbA1c level among the groups. Let us just copy paste this. Our alternative hypothesis will be there is a significant difference mean initial HbA1c level among the groups. Let us just copy paste this. Our threshold is alpha of 0.05. The resulting p-value that we have is 0.678. We will type here our p-value of 0.678. Do not reject the null hypothesis. We can conclude that there is no significant difference in then let us just copy paste the statement from above. We will try to do this in other variables and we'll fast forward the process. Let us just review the first scientific inquiry that we have done. Is there a difference in the mean initial HbA1c level among the groups? These groups are those without formal education, with elementary education, with high school education, with bachelor's education, with master or PhD. Our null hypothesis states that there is no significant difference. Our alternative hypothesis states that there is a significant difference. Here in the result, our p-value is 0.0678, which is bigger than 0.05 value of alpha. We will not reject our null hypothesis. We can conclude that there is no significant difference in the mean initial HbA1c level among the groups. Next, is there a difference in the mean HbA1c level among the groups after 6 months? You can see here in our box plot, This is group 4. The group that has finished Masters or PhD has lower average HbA1c in comparison to the rest of the groups. However, is there a significant difference in this comparison? The answer to that is no, because the p-value is 0.179, which is bigger than our alpha. We will not reject our null hypothesis. We can conclude that there is no significant difference in the mean 6-month HbA1c level among the groups. How about the average HbA1c level after 12 months? Here in the box plot, group 4 has lower HbA1c level compared to other groups. However, this is not significant because the p-value is 0.259, which is bigger than our alpha. We will not reject our null hypothesis, and we can conclude that there is no significant difference in the mean 12-month HbA1c level among the groups. Next, we now go to our mean initial systolic blood pressure. Our scientific inquiry: is there a difference in the mean initial systolic blood pressure among the groups? Our null hypothesis states that there is no significant difference. Our alternative hypothesis states that there is a significant difference. When we look at the box plot, you can see that the gray lines are very near each other. The p-value that we got is 0.88. This is bigger than our alpha. We will not reject our null hypothesis. There is no significant difference in the mean initial systolic blood pressure. Next, is there a difference in the mean 6 months systolic blood pressure among the groups? Null hypothesis states there is no difference, while the alternative hypothesis states that there is a difference. Just eyeballing the gray lines, you can see that they are very near each other. The p-value that we got is 0.847, which is bigger than the alpha. We will not reject our null hypothesis. We can conclude that there is no significant difference in the mean systolic blood pressure after 6 months among the groups. How about in 12 months? You can see here, the group labeled 0 is quite higher than the rest of the groups. However, it is not significant since the p-value is only 0.057, which is bigger than the alpha. We will not reject our null hypothesis. We can conclude that there is no significant difference in the mean 12-month systolic blood pressure among the groups. Next, how about the diabetes duration? It is still the same. The p-value is 0.407, which is bigger than alpha. So, we will not reject the null hypothesis. We can conclude that there is no significant difference in the mean diabetes duration among the groups. Is there a difference in the mean age among the groups? The youngest is probably at 20 years old. The oldest is probably at 85 years old. As you can see here, the gray line of group 3, 2, and 1 are very near each other. Then group 4 and group 0 broke off. Those that belong to group 0 are the oldest group on average. This is followed by group 4. The p-value that we got is 0.002. This is smaller than alpha of 0.05. This means that we will reject our null hypothesis. We can conclude that there is a significant difference in the mean age among the groups. At least one of the group is different from the rest. The rest of the group here is group 3, 2, and 1. They have an average less than 55 years old. Group 4 has an average of 59 years old, while Group 0 has an average of 62. We can say that groups 4 and 0 are different from the rest. Next, is there a difference in the mean BMI among the groups? You can see here groups 3, 1, and 2 have very neat and almost overlapping average body mass index. Groups 4 and 0 has a lower average BMI. The p-value that we got is 0.094. This is bigger than our alpha. We will not reject our null hypothesis. We can conclude that there is no significant difference in the mean BMI among the groups. Is there a difference in the mean literacy score among the groups? Here in our box plot, Group 0 has the lowest literacy score on average, followed by Group 1. You can see that there is a trend that the higher your education level, the higher your literacy score. The p-value that we have is 0.000, which is smaller than the alpha. We will reject our null hypothesis. We can conclude that there is a significant difference in the mean literacy score among the groups. At least one of the group is different from the rest. If you will see here, group 0 is literally far from the rest. They have an average literacy score of 20, which is the lower end of the interval of group 1, even though group 1 has an outlier. Next, what about the mean improvement? Remember that the variable improvement is derived from the column difference in the data table, which is the difference between the 12th month and the initial HbA1c level. You can see here, the gray lines are very near each other. The p-value that we got is 0.906, which is bigger than alpha. So we will not reject null hypothesis. We can conclude that there is no significant difference in the mean improvement among the groups. Now let us compare the income groups. Remember that our dataset did not have additional meta details. I don't know what income brackets did they use to be able to come up with these groups. For the sake of discussion, we will just address them as the group numbers. Our scientific inquiry: is there a difference in the mean initial HbA1c level among the income groups? Our null hypothesis states that there is no significant difference, while the alternative hypothesis states that there is. The p-value that we got is 0.601, which is bigger than alpha. We will not reject our null hypothesis. We can conclude that there is no significant difference in the mean initial HbA1c level among the income groups. Next, is there a difference in the mean 6 months HbA1c level among the income groups? The answer is no, because our p-value is 0.773, which is bigger than alpha. We will not reject our null hypothesis. How about after 12 months? As you can see, the gray lines are very near of each other. The p-value that we got is 0.963, which is bigger than 0.05. We will not reject our null hypothesis. Now we go to the initial systolic blood pressure. Eyeballing, you can see that the gray lines are very near each other, but this group 0 has the highest average among them and is quite far from the rest. Group 0 has an average of 142 millimeters mercury, while the second highest has an average of only 134. The p-value that we got is 0.027, which is smaller than alpha. We will reject our null hypothesis. We can conclude that there is significant difference in the mean initial systolic blood pressure among the income groups. At least one of the group is different from the rest, and we can say that the group is group 0. Next, after 6 months, is there a difference in the mean systolic blood pressure among the income groups? You can see here, the gray lines are very near each other. We see that the p-value is 0.856, which is bigger than alpha. We will not reject the null hypothesis. Next, after 12 months, looks the same. We have a big p-value of 0.374, which is bigger than alpha. We will not reject our null hypothesis. Average diabetes duration. As you can see, the gray lines here are very near of each other. Group 4, 2, and 3 are really near. Then a little farther away is group 1 and 0. However, is this significant? Well, the answer is no, since the p-value is 0.205, which is bigger than 0.05. We will not reject our null hypothesis. We can conclude that there is no significant difference in the mean diabetes duration among the income groups. How about the average age? Is there a difference in the mean age among the income groups? You can see here, group 3 is the youngest at 48 years old, and then group 0 is the oldest on average at 58 years old. The p-value that we got is 0.0178, which is smaller than alpha. We will reject our null hypothesis. We can conclude that there is a significant difference in the mean age among the income groups. At least one of the group is different from the rest. Now, our box plot is quite confusing because we don't know which group really is different from the rest. Is it the group 3, which is the youngest, or group 0, which is the oldest? We don't know which. What ANOVA can tell us is at least one of the group is different from the rest. Is there a difference in the mean BMI among the income groups? The p-value that we got is 0.943, which is bigger than 0.05. We will not reject our null hypothesis. We can conclude that there is no significant difference in the average BMI among the income groups. Next, is there a difference in the mean literacy score among the income groups? You can see here, Group 0 has the lowest literacy score on average. Group 4 on average has the highest. The p-value that we got is 0.032, which is smaller than alpha. We will reject the null hypothesis. We can conclude that there is a significant difference in the mean literacy score among the income groups. At least one of the group is different from the rest. You can see here in our box plot that the distance of gray lines are similar for group 0, 1, 2, and 3. Then suddenly, there is a big distance of gray line for group 4. We can say that group 4 is the one different from the rest. How about the improvement? The p-value that we got is 0.53, which is bigger than alpha. We will not reject our null hypothesis. This is the end of our lecture. If you have comments or feedback, please comment it below the videos. Then like this video and subscribe to my channel. Let us see each other again on the next video for us to learn statistics together.